Hello and welcome to this video on type order and the more general than relations in Hindley-Milner. In previous videos, we've looked at Hindley-Milner types, where we've got monotypes and polytypes. We've also looked at substitutions, where we've got these sets of mappings, and we've also looked at how that applies in type systems, where our mappings are from type variables to monotypes. What we're going to be looking at today is that some types are more general than others. So take this type for all alpha, for all beta, alpha to beta, basically a function from anything alpha to anything beta. We can say that this type is more general than something like this, which is for all alpha, alpha to bool. So you can see here we've kind of replaced the beta with bool. And again, it's a function type from anything to bool, which is obviously kind of more restricted or somehow less general than the first type. And we can actually restrict it further, make it less general again, and we get int to bool. So again, going up, we'd say we're getting more general, going down, we're getting less general. The way we might write this is we use this square less than equal sign or subset equal sign. And what we're saying here is that the type on the left-hand side is more general than the type on the right. So for all alpha, for all beta, alpha to beta is more general than int to bool. So looking at the syntax more closely, it is kind of less than or equal like. So for example, we'd say that something is always this kind of more general or equally general to itself. If we wanted to, we could maybe say something is strictly more general than, so we remove that line at the bottom. So for example, for all alpha, alpha is strictly more general than int. And in fact, for all alpha, alpha is the kind of minimal element of this partial order, because for all alpha, alpha basically means any type at all. And so everything is going to be less general than that. So given that, can we come up with a formal definition? And yes, we can. We can say a type 1 is more general than a type 2 if there is a substitution S that maps the for all quantified variables in type 1, and that substitution applied to type 1 is equal to type 2. Maybe that helps, maybe it doesn't. Let's look at some examples and see kind of what this definition really means for our examples. Going back to the same example where we have this very generic function type, we can think about what substitutions are being applied so that we're kind of going down and getting less general. So in the first case, the for all quantified type variables are alpha and beta. What can we apply? Well, here it looks like we've gone from beta to bool, and that is what we have done. So beta is for all quantified, and we've mapped it to bool, and we get the second line, which is for all alpha, alpha to bool. And again, going to the next one, maybe pause now and think about what substitution we've applied. Here we've applied alpha to int. That's pretty straightforward. And if we wanted to, we can actually just jump the whole way. So the top line is still more general than the bottom line. And we can do it in one big substitution. When I say big, it's got two entries, but effectively it's the combined substitution of those two. We've got beta to bool and alpha to int. We can also do this for other types. So for example, here we've got this very generic function type. So any kind of function will be less general than this. And here we've got an int to a list of bools. And again, we can just do this mapping as we did before. We've got beta goes to list of bools and alpha goes to int. Also note that this doesn't stop us introducing new type variables or having type variables in the final kind of output. So for example, we might try mapping beta to a list of gammas. That would also be perfectly valid. Note that the gamma isn't for all quantified, so you couldn't kind of go less general than this, but you could then do something interesting with this type nonetheless. So that's been a brief run through of type order and the more general and less general and more general or equally general relations. We'll see how we use these in future videos as we look at instantiation and generalization. See you in the next one.